Record button. Okay, welcome everybody to our weekly seminar. Today we have the pleasure of having Hongying Zhao from the South Florida Water Management District. She is the Flood Protection Level of Service Program Manager. She's very experienced in the area of flood protection, stormwater treatment area performance, and many other areas in water resources engineering. She has a PhD in civil and environmental engineering from the University of Kansas and a master's and bachelor's degree in water resources engineering from Wuhan University of Hydraulic and Electric Engineering. So I'll turn it over to you, Dr. Zhao.
Sure. Yeah. Hey, good morning, everyone. And it's truly a pleasure to present at this seminar. In today's presentation, I will first present an overview of the water management system in South Florida region, and also the flood protection level of service program. Then I will present an ongoing case study, which the name of the study is C8, C9, Watersheds, Adaptation and Mitigation Planning Study. So I hope you all enjoy it. In South Florida, the water management system actually is quite complex. We have over 2,000 miles of canals and levees, and 160 or plus major drainage basins, and also over 14,000 water control structures, including 71 pump stations. We have 6,000 acres of large-scale constructed stormwater management areas, and also 450,000 acres of Lake Okeechobee, and 960,000 acres of water conservation area. So that is truly a lot of assets to manage. The Flood Protection Level of Service Program is a program designed to ensure how the flood control assets are up to the task, considering development, future land use, climate change, like sea level rise, future rainfall increase. This program assesses level of flood protection throughout the 16 counties, identify at-risk structures and needed improvements to operations, canal conveyance, or structures. This program also provides a formal process to initiate retrofit and adaptation efforts for future infrastructure improvements and or modification of regulation criteria. Throughout this program, we always incorporate resilience into the design standard and also constructions. This program requires a close collaboration with local government entities, drainage district, and other agencies with flood control or related responsibilities, such as U.S. Army Corps. The program is designed into 3 phases. With phase 1 assessment, the focusing of phase 1 is always on the primary canals system to identify flood vulnerability assets and also the flood vulnerability areas. If any deficiency or vulnerabilities are identified, a phase 2 study will be recommended. A phase 2 study is about mitigation and adaptation planning, focusing on primary, secondary, and tertiary systems. In phase 2, we work together with local partners, stakeholders, and the local drainage district to identify projects, operations, or regulations to meet the flood control needs. Phase 3 is about the implementation. This phase is to design, permit, and also build projects to achieve flood protection goals. The project will be integrated into the sea level rise and the flood resilience plan. So that's the overview of the water management system in South Florida region, and also the overview of the flood protection level of service program. And next, I want to present an ongoing CA-C9 watersheds flood protection, adaptation, and mitigation study. The map on the left shows the project area, CA basin, and the southern part of C9 basin are located in Miami-Dade County, and the northern part of C9 basin is in Broward County. The phase 1 study, like I just mentioned, is about assessment. So the assessment was completed in year 2020, and the phase 1, during the phase 1 study, we focused on primary systems, and also we evaluated the effect of sea level rise. Let me minimize this panel. Okay, evaluated the storm surge, land use change, and also how it will impact the flood protection level of service. We simulated current condition with just 4 storm events, including 5-year, 10-year, 25-year, and 100-year surge and rainfall. And for the future conditions, we assessed the same 4 return period with storm surge, and also we assessed sea level rise with 1 foot, 2 feet, and 3 feet sea level rise, future groundwater level, future land use, and also some planned future projects are all included in the future condition assessment. This slide shows the peak discharge in a unit of cubic feet per second per square mile for current condition, and also under 3 sea level rise scenarios for a 25-year event. And as the blue line is represents the discharge capacity for the current condition, and then the orange line is for the 1 foot sea level rise. The gray line is for the 2 feet sea level rise, and the last, this yellow line is for the 3 feet sea level rise. So we used a 12-hour moving average to calculate the peak discharge. The reason we use a 12-hour moving average actually is to cancel out the tidal effect. This plot actually shows clearly the impact of sea level rise. In comparison to the current condition, we can see peak discharge at the structure S29 for C9 Canal is reduced by about 50%. So this basin is vulnerable to the sea level rise. The recommendation from phase 1 study is we need to advance to the phase 2 study, which is the adaptation and the mitigation study. The CAC9 phase 2 adaptation study in collaboration with Miami-Dade County and also Broward County was initiated August last year. And that's the fun part. We got to play with a model that was calibrated and validated. And also we got to play with local and local drainage district and our partners to study or to develop a overall strategies together through a collaborative process. We launched a website to collect some local level projects that have already been proposed or under construction. And that's the starting point. Build on that, we also developed a strategy for the phase 2 study. Like I just mentioned, the objective of adaptation and mitigation study is to work with partners and the stakeholders to develop cost-effective adaptation mitigation strategies and develop a optimized implementation plan. This slide shows the critical tasks of these projects. We started with stakeholder partner engagement, and this is a workshop we hosted in I think it's in University FIU campus. And other sequential projects include H&H assessment, economic assessment. The economic assessment including several components. First, we calculate the flood damage reduction estimate in terms of dollar amount. Then we also calculate the cost of each mitigation strategies proposed. Then we calculate the cost benefit estimate to recommend what is the most which strategy give us optimize the benefit cost ratio. Then after that, we will use an adaptation pathway planning approach to sequence the project. Which project should be implemented first and what goes next? That's the another key component of this study. And the last step is to present to the public or stakeholders about the overall strategy developed. This slide shows some of the examples of flood mitigation solutions. On a regional level, we will maybe a forward pump. This S26 forward pump is located in Miami-Dade County, which has been constructed for a while, and also some large-scale emergency detention basin. This is also a constructed facility in Miami-Dade County, and flood wall, C4 flood wall. All of these are the typical regional level projects. And local level projects can include the flap gate and some flood burial, and also increase some canal bank elevation, and also some seawall, and all of these are good local level mitigation strategies or projects. Under the CAC9 adaptation and mitigation study, this slide shows a preliminary developed regional level strategy. We call it M2A. Under this strategy, it includes the forward pumps at S28 and S29, and also increase the gate top elevation to prevent the overtopping, and also add tieback levees to prevent bypassing. And this regional strategy also includes 500 acre-feet distributed storage to mitigate some local level flooding that probably do not have the conveyance to be convented to the primary canal. And also, of course, we also include the canal improvements to return to the design conditions. So that's a regional level strategy. We call it M2A. And I can also show you some of the benefits simulated by implementing this strategy. Okay, so this slide compares the peak stage profile for along the C9 canal, which is about probably 10 miles from west to the ocean side. This slide compares the 25-year 2-feet sea level rise peak stage profiles for no mitigation. It's mitigation 2A, 2B, and 2C. I just talked about the strategies for M2A, and for M2B and M2C, they are more aggressive, including large pump sites and also some canal enlargement options. So if we implement M2A, it will lower the canal peak stage profile by about 0.2 to 1.5 feet along the canal, 10 miles of canal. And if M2B is being implemented, it will be lower the canal peak stage by about 0.2 to 1.8 feet. And if we implement M2C, the peak stage profile will be lower than the current condition. So this plot shows the 4 different peak stage profiles. And the local level project also are very critical to be included in the overall mitigation strategies. Some of the typical local level projects, including stormwater system improvement or rehabilitation, and also add some small sluice gates or local pump to pump the water to the primary canal, and also add some conveyance culverts. All of these are very good local level mitigation projects. The local level projects provide benefits from different aspects. For example, it allows operational flexibility, and also it enhances the local level flood control and improve the secondary or tertiary conveyance, which are also very critical to be able to reduce the flood depths quickly. And another benefit is like local pump, it will allow the pre-storm drawdown, which is a very typical operation strategy we used. We wanted to lower the canal when we know a storm is going to hit us very soon. And another thing is the local level project will improve storage utilizing efficiency. For example, if we have the conveyance needed between two areas, and if one area got hit with heavy rainfall and another area actually still have some storage available, those conveyance culverts definitely can help to temporarily convey some water to the other storage area. So these local level projects are also critical components of the overall strategy. The overall strategy also includes green infrastructures and nature-based solutions. For example, installation of a living shoreline along a canal and vegetated flood burn to enhance flood protection through retention and detention, and also temporary storage in open areas like some maybe baseball field. It's actually maybe used temporarily, or golf course, maybe temporarily used as a storage. And also, we also promote the green space for bioretention and infiltration, which provide both the flood reduction benefit and also water quality benefit. And another green infrastructure solution is to enhance infiltration, groundwater recharge, and storage. These are some typical solutions we developed during a phase 2 study, and during the phase 2 study, which is a phase 2 implementation, more green feature and then nature-based solutions can be incorporated. This slide talks about the economic assessment. The district developed a FIA tool which calculates the expected annual damage based on the flood depths. And this tool, we calculate this, we do this type of calculations for all the scenarios we talked about. We have 2A, 2B, and also 2C, and we calculated the flood annual damage. We are not going to completely eliminate the damage. So what we are actually calculating is a damage reduction. And we calculated this type of reduction for all the scenarios. Then the calculated damage in terms of a dollar amount, it will help us to answer critical questions such as what liability or risk is the system exposed to due to action or inaction. And when combined with the cost for each strategy, we can also identify the best cost benefit ratio and also which strategy should be selected. So this type of calculation is being conducted for all the mitigation strategies. And the last step of this overall mitigation plan development is called decision making under deep uncertainty, or we call it dynamic adaptation pathway planning. So the overall strategies include a suite of projects, and not all the projects can be constructed at the same time. And this pathway planning allows us to actually sequence the projects to maximize the benefit of different projects. So throughout this planning process, we will identify which project need to be constructed first, and also how was the decision made. This pathway planning will provide us the information needed to make those type of decisions. So that's the last step. We call it dynamic adaptation pathway planning. And there's a book actually talking about, and this book is free. If any of you are interested, you can find it. It's called the Decision Making Under Deep Uncertainty, from Theory to Practice. So basically, that's the overall process we followed for this mitigation adaptation strategy study. Throughout the process, we were faced with many challenges. For example, how to fairly evaluate or select a project with other social or cascading benefits, because so far our benefit analysis was focused on the flood reduction, but there's some social cascading benefits. They're also important to be counted. And another challenge we faced is how to evaluate solutions across the project scale and the flood management tiers. We talk about we research the project at the primary level, secondary or the tertiary level, but if we talk about the large pump station, of course, we will see a big benefit. And there's a lot of the local level projects, like I just mentioned, a sluice gate and a small pump. They also have benefits from different aspects, but how do we compare those benefits from different aspects? That's some challenge we faced. And how to identify opportunity for phased implementation, targeting no regret strategy immediately. For those primary large scale or regional level projects, it takes time to construct. And some of we cannot like wait to we are having sea level rise one and wait for 10 or 15 years, then we start to construct. It will probably be too late. So that's why we call it, some projects need to be promoted to the early design. So in order to really meet the challenge before we are actually hitting those sea level rise. So those are some challenges. We do not have answer for all for those challenges. We are also learning, but those are some critical questions we need to answer. And throughout this process, we also learned a lot. And I want also to share with you, I guess, the lesson we learned. For example, we learned collaboration is key. To have a plan that really addresses the issue, not just for primary, it also covers the issues for tertiary and the secondary and tertiary system. We really need to collaborate with local government, stakeholders, partners, local drainage district. So collaboration is the key. We also learned we need to use a basin-wide coordinated approach to truly understand the local and the regional priority needs. And another important lesson we need is we need to use a hybrid approach. So it's not just about the gray pump station or those ones. We do need to include green infrastructures and the nature-based solutions in the overall strategy. And we also learned the no regret actions in the short term, but the overall strategy needs to be robust and also adaptable, evolvable in the long term. So these are some quick summary of the lesson we learned. And I think this is my last slide. With that, I wanted to thank you all very much for giving me the opportunity to present this study and also to share with you the South Florida water management system and also our level of service program.
Okay, thank you very much, Dr. Zhao. We are open for questions if anybody has any questions on the seminar that was just presented.
Yes, Dr. Chin, may I ask a question?
Yes, Wafa, go ahead.
Yeah, thank you so much for your presentation. I have a question about slide number 12.
Okay.
To know, yes. Yeah, here you gave a presentation about the local level projects, but I didn't get the point about what's the definition of the local, what is the size for those communities, and how those local parts of Miami-Dade can collaborate together. I mean, Miami is not a small area, we can say from South Miami to Jupiter or that area, they are all connected. And if there is a flood, it comes down or whatever, how they can manage that? I mean, if it's a wider project would be much better than the local one.
Okay, yeah, these are very, very good questions. So for the local level, for this study,
yes, what's the size? May I ask, what's the size for those local?
What is said for local, it depends. Like for the, when we talk about our pump station, we are talking about maybe 3,000 CFS, okay? And we are talking about maybe a 40 by 80 feet wide gates, several gates. There's so many these type of large structures around the Miami Biscayne Bay area. But when I talk about the local level projects for the gates, it probably will be maybe 8 by 6 feet wide. And talk about local pump, it varies from maybe 50 CFS to maybe 150 CFS, or maybe slightly large. And when we talk about the conveyance culverts, it could be someone can maybe even in a community that's to connect several lakes. It may be in a diameter of maybe 3 feet or 4 feet, but that's a type of the local level projects. And in this map on the right side, those dots actually are the local project we collected. You can see those some of the orange dots, it may represent the local level conveyance culverts underneath a community road.
Yes.
Okay. Yeah. And when I talk about the primary, I'm really there's only 2 primary canals in these 2 basins, C8 canal, C9 canal. And then when I talk about the local, regional level, primary or regional level, we only have 2 large structures currently in these 2 watersheds. That's S28 gated spillway and S29 gated spillway. Both of them are larger than 3,000 CFS gated structures.
And is there any online system for that management? Since you mentioned if one of the local sites has some capacity yet, I mean, for their storage, it can be directed to their storage from one place to another one. Is there any online monitoring to see where they have still space or not? I mean, how it's going to be connected to manage these flood?
Okay, actually, we operated the primary system in order for the secondary and the tertiary can send their water to our system. So that's the overall strategy. Okay, we make sure the primary canal have the capacity, and then the secondary system want to make sure they can send water to our system, and then the tertiary system, they want to make sure they can send water to the secondary. That's a three-tiered system. And also some of the 298 drainage district, they have very good monitoring sites. For example, I know the South Broward County Drainage District. Actually, they have several local pumps. They monitor the stage all the time. And we
Yes.
also, the district water managers talk with them all the time, especially when now a storm is going to hit us. They will have meetings. They say, can you lower your secondary canal now? So when the storm really hit, we have the capacity to hold a little more water to reduce the flood.
Yeah, thank you so much. Thank you so much.
No problem. Good, very good questions.
Welcome.
And
Okay,
actually, the picture here is at the South Broward Drainage District. And this gentleman actually is their director. They're showing us their systems. Yeah.
Yeah, I got it. Thank you.
okay. Any other questions for Dr. Joe?
I have a question.
Okay, Shruti, go ahead.
Thank you for the talk, Dr. Zhao. I had a question on slide 6.
Okay.
I think you were showing discharge on that.
Yeah.
Yes. So do you also consider the mitigation strategies when you are modeling the discharge, or mitigation strategies are not considered for this?
Yes. Very good questions. Yeah. For each mitigation strategies we simulated, we look at the peak discharge to see. Actually, we have 6 performance metrics we use for this type of assessments. And what I'm showing here, we call it is a PM2, which shows the conveyance capacity. And for each mitigation strategies, we look at our first metrics is peak stage profile to see if the strategy is going to help reduce the peak stage profile and the different sea level rise conditions. And we also look at the overall flooding to see, okay, by you implement these mitigation strategies, will it help to reduce the flood depths, or will it help to reduce the flood duration? And we also look at, okay, by implementing these different strategies, can we restore some of the discharge capacity at the gated spillway at the structure site? So yes, we do look at all of those kind of metrics. We use it to assess the effectiveness of the different strategies.
Okay, thank you. There's one more question, maybe more broader.
Okay.
Like, what were the actions taken by the South Florida Water Management District when Storm Nicole hit South Florida? Like, were there some actions taken?
Okay. Yeah, actually, I'm very glad to talk about this because I was in lockdown under Hurricane Ian, not in Nicole, and Nicole is much better. Ian was very worse. So typically, we have a meteorologist on site. So they will provide the forecasting. In addition to the National Weather Service, they also monitor the rainfall, the intensity, the tropical storm. So it could be the hurricane. They monitor all the components from the meteorology aspects. And if they think this is a very big event, and they will communicate with our water managers. So water manager will start the preparation early before the storm hits us. And for example, they will start to started to talk to the local drainage district to say you need to start lower the secondary canal. Okay, so basically this one we call it pre-storm drawdown. It's a very typical operation. And then they will also make sure all the field stations are in good preparation mode. And for example, they may need to deploy some of the local pumps to different areas, depends on where the hurricane or tropical storm hits. And we will also work with those field stations. And depends on the how severe is the storm. And we have the emergency operation center, like for both Ian and also Nicole, the emergency operation center will be activated. And then that's our top priority. We will have a group of modelers, and then we monitor the conditions, and we have the briefings, at least 2 briefings in the morning, and all type of the emergency operation, the activities will be activated. And then based on that, the decisions will be made. So that's actually a very intense, very stressful situation. Yeah, we just had 2 this year. So that's hopefully no more this year.
Yeah, I have a follow-up on this slide 6 also.
Okay.
So as the sea level rise increases, then the discharge capacity generally decreases. So it seems that you are sort of fixing like the flood elevations or something like that is being fixed, so that you're seeing that, okay, if the elevations don't go above a certain level, then your discharge per square mile is decreasing. Is that correct?
Yeah, with the sea level rise and the storm surge, and the tailwater condition will be increased, which prohibit maybe the full discharge capacity of the structures. And I think this slide is for the phase 1 study. Basically, there's no mitigation strategy, and we just look at how it will affect the discharge capacity in the structure. Yeah, this is from phase 1 study with no mitigation strategy.
I see. And for mitigation, you identified green infrastructure and gray infrastructure. So, I mean, under the most optimistic scenario, how effective would that infrastructure be in, let's say, reducing the discharge requirements of the canal?
Okay, that's a very good question. And I want to be very honest with you. During a heavy, large, like a 50-year, 100-year event, this green infrastructure will not make a big difference in terms of the discharge. Because I think the important part of this green infrastructure probably is from the water quality perspective.
Yeah.
Yeah, because the storage of this green infrastructure is just limited.
Yeah. Okay, thank you. Are there any other questions for Dr. Zhou? Well, if none, then I want to thank you very much for your outstanding presentation today. It's been very illuminating for us. And yeah, I think we'll sign off now for everybody. And thank you again, Dr. Zhou, for your presentation.
Thank you so very much.
Thank
Yeah,
you.
thank you for the opportunities. Thank you.
Yeah.
Bye-bye.
Bye.
Have a nice weekend.
Okay, bye,
Yeah.
everybody.